Hello everybody, this is the video clip for chapter 2 and we still about the derivative of a function. So for this one, we are going to find a derivative of the inverse trigonometric function using the implicit differentiation. Okay, so previously what we have done is to find a derivative of the implicit defined function. Okay. So for example, if you want to find a derivative of arc sine x, okay, don't forget that if you have y equals to arc sine of x, is the same as you got sine of y equals to x, okay? However, your y, it is ranging from negative pi over 2 to pi over 2, okay? And also, we also know that a cosine of y is simply a square root of 1 minus x squared, because right now your x is a what? Your x is a sine, right? So 1 minus sine square y is taking a square root, it is a cosine. And because right here is a pi over 2, right there is a negative pi over 2, both uh, on both region, your cosine of y is non-negative. So it means that we just use a positive branch of a square root. Okay. Now, if you want to find a derivative, actually what we need to find is we need to find a derivative of y, okay, of this function, right, which is the arc sine. So we use the implicit, this one is the implicit differentiation, right, by taking a derivative with respect to x both sides. So the first one becomes a d by dx of sine y, and on the right hand side you got a derivative of x with respect to x. So here easy, right, it is 1. But this one you use the what? You use the chain rule, the integrate of sine, it is a cosine, and then a derivative of the inside, which is what you need. So if you want to solve for dy by dx, this one, you just simply move the cosine from multiplication into a division here. However, I mean, in terms of x, because actually at the beginning, the function that you got at the beginning, it depends on the x alone. So you should change your cosine of y into a function of x. And we have it here that cosine of y is simply a square root of 1 minus x squared. So it means that a derivative of the arc sine, it just simply becomes 1 over a square root of 1 minus x squared. And your x must be, the absolute value of x must be less than 1. Okay. How about the other one? Okay, we actually can show like similarly that the arc cosine, if you want to find a derivative, it is pretty much the same, you see, as we told you before, that they usually come as a package, right? Right? The arc sine, the arc cosine, like pair up together, they got the same function, but a different sign. And again, the negative sign come with the function that has a co again. So this one has a cosine, so it becomes negative 1 over a square root of 1 minus x squared. Okay. What if we look at some other things, okay, some other pair, for example, y equals to our tangent, okay? So now we again take a tangent both sides. So we have the tangent of y equals to x, because we know how to find a derivative of the tangent, right? And we know that secant square of y equals to 1 plus tangent square of y. This is what you really need to know, right? And then your tangent square of y is simply a x. So the secant square of y, actually it is 1 plus x squared. Okay. So again, using the implicit derivative, okay, you take a derivative with respect to x both sides, okay. On this one, it is a derivative of x with respect to x, but on this one, it is a derivative of tangent of y with respect to x. So you use the chain rule, derivative of the tangent is simply secant square. This is what we have before. But then this one, by chain rule, you need to find a derivative of the one inside with respect to x. This one is pretty easy, right? Derivative of x with respect to x is 1. And you need to solve for dy by dx. So we just simply divide the 1 by secant square y. But this secant square y has the relation here that it is 1 plus x squared. So this means that a derivative of the arctangent with respect to x, it is simply 1 over 1 plus x squared. Okay. So here is what we have. All right. So again, there is the pair up. Again, you see the tangent and the cotangent, they're paired up together. However, the thing will different by a negative sign. Okay. And later on, if you want, you can try to find the derivative of the arcsecant, okay, and it is becomes 1 over the absolute value of x square root of x squared minus 1. So it depends on whether your x is positive or negative, all right, and they're pairing up with the arccosecant of x, okay, which will be the same function but a different of negative here. So again, all the co will have a negative and all the one without the co will have a positive, okay? And if we attach them with the chain rule, okay, we may write it down in this way. For example, the arc sine of u, it is 1 over a square root of 1 minus u square du by dx. And if you want to find a derivative of the arc cosine of u, it will be 1 over square root of 1 minus u squared du by dx with negative, right? Because it has a co, okay? And this one as well, you may have d by du of arctangent of u. It is 1 plus 1, 1 over 1 plus u squared du by dx. And for the arc cotangent, okay, I'm sorry, a u, it becomes 1 over 1 plus u squared du by dx, and they have a co, so you got a negative. Okay, you got a negative in front, and a derivative of the arc secant of u, it will be 1 over the absolute value of u square root of u squared minus 1 du by dx. And the last one, okay, the arc cosecant of u, it is negative 1 over the absolute value of u square root u squared minus 1 du by dx. Okay, so this one we attach the thing or the formula that we got with the chain rule. We have it this way so that you can find a derivative of this kind of, you know, complicated function. So here, can you see that we got two functions multiply each other? So the first thing that you need to do is the product rule. And then this one, you see that instead of x, you have the u here, and your u is e to the x. So you need to use the chain rule for the, for the second term, okay? So for your y prime, it is the first, and then derivative of the second, derivative of the arc sine, it is 1 over square root of 1 minus u, okay? It must be u. So, and your u is e to the x square, and then a derivative of the inside, okay? And the one inside right now is e to the x. So you have e to the x multiply, okay? So by multiply, it, when you have fractions, okay? When you multiply, it must be multiplied on the top, okay? This is very important. So here is the first derivative of the second plus the second, and then derivative of the top, which is the x cubed. So you got 3x squared. Okay, so this one you may would like to, if you want, then this one can be simplified a little bit into like 1 minus e to the 2x. Okay, because e to the x and then square is the same as e to the 2x, and then plus 3x squared and arc side of e to the x. We good? Yeah. So this one, you can see that, hey, actually, this is the arctangent of x and then raised upon -1. So we can simply use a chain rule by looking at it as what? Gx raised upon r, right? So we got your y prime as 3 and then kick down that power and your power lower by 1 and then a derivative of the one inside, which is a derivative of the arctan. The arctangent becomes 1 over 1 plus x squared. Okay. Oh, this one lower by 1, so it must be -2. Or you can rewrite it into 1 plus x squared and arctangent square of x. Okay, this one you can rewrite it in this way as well. How about this one? You see that it is the implicit define, right? Your y square, it is within all the others or other function. So it means that this one is the implicit defined function. So if you want to find a derivative at this particular point, it means that you just simply find a derivative, of each of the term, both sides. So the first one, it will be a derivative of x squared, x over 2. So you got 1 over 2. And then a derivative of arctangent of u, it will be 1 over 1 plus u square. And then a derivative of the inside, okay, equals to the arcsecant, it is 1 over as the absolute value of u, square root of u square minus 1. Okay, right now here the whole thing is your u, and then a derivative of the u, which is 3x plus 2. Okay, so here you got a 1/2 and then 1 plus y fourth, right? And then this one is 2y y prime. You just simply use the chain rule, is it? And this one, it is like 3, right? 3 over, oh, sorry, this is equal. This whole thing, okay, square root of 3x plus 2 square minus 1. As we told you, you don't really need to do any simplification because we are going to find the y prime at this particular point. So you are going to plug in your x as 0, your y as fourth root of 3. Okay, so it becomes a what, 1/2, and then this one is like 2 and the third root of, sorry, a fourth root of 3, and then over 1 plus fourth root of 3 square. And this one, we still have y prime at 0 right here. Okay, this term equals to 3 over, your x is 0, right? So you have 2 square root of 2 square minus 1. Is it? Okay. So your y prime at 0 is simply what? This is square root of 3, right? So this one cancel with that one. So you have square root of 3 over 2, and then subtract by 1 over 2. So you have this one minus 1 over 2. And then here we have what? At the bottom, you got 1 and 3, so you have 4, right? The whole thing here. So the 2 and the 4 canceled, okay? So you are going to multiply the whole thing by 2 and then divide the whole thing by the fourth root of 3, okay? And if you want, then it is a what? Square root of 3 minus 1 over the fourth root of 3. This will be the derivative at this particular point, y x0, y is fourth root of 3. Okay. So we would like you to do the exercise on section 3.5, okay? Number 5 to 30, 35 to 40, to 40 and 49 to 60. Okay, so that you like get yourself familiar with how to find a derivative implicitly. Okay, so let us continue further as we can see that, hey, from the implicit differentiation, you can find a derivative of the inverse trigonometric function. So how about the exponential? Because we all know that derivative of a to the x, it is what? A to the x log of a. And the exponential has a inverse as a logarithm. Okay. So right now, what we are going to do is to find a derivative of the logarithm function. So let us recall a little bit that if you have x equals to a to the y, it is the same as you got y equals to log of x base a, okay, log of x base a. And we also have this kind of relation that a raised to power log of x base a become an x, okay, if your x is positive, and the log of a raised to power x base a equals to x if your x are all their number. Okay, so we got this kind of relation. So it means that log and the exponential, they are inverse of each other. Okay, and in the case that your a is e, if the log is the base, like from the natural from the number e, then instead of using log of x base e, we use the word the symbol, the notation lnx, which is called a natural log of x. Okay, or a log of x, we still read it as log of x. Okay, and we also have this kind of relation. Okay, the first one is that a log of two number multiply, it means that you got two log, okay, two logs, okay, added. If you have a log of two number divided, you got two logs subtracted. If you have a log of w raised to power something, that power can kick out here, and then you end up with log of w here. And log of e is simply 1, log of 1 is simply 0. And if you got e raised to power log of z, is the same as z. Okay, so it is actually just this one, right? Okay, so of course, I mean, your z must be positive. Okay, okay, actually, all the from here, all the it's not all, sorry. For this one, your z and your w must be positive. For this one, your w must be positive, and for this one, your z must be positive. Okay, so now we would like to find a derivative of a logarithm of x base a. Okay, so again, we use this kind of relation that if your y equals to log of x base a is the same as x equals to a to the y, and you are going to find a derivative implicitly, you see, the implicit derivative. So you take a derivative both sides. It happened that a derivative of x, it is one, simple, but then a derivative of a to the y, it is a to the y log a, and then the chain rule y prime. And what you need is only the y prime there. So it means that your y prime is simply 1 over this whole thing, right? A to the y log a. But a to the y is a what? Is dx, right? You see, your a to the y is simply the x itself. So it means that your y prime, it is 1 over x log of a. Okay, and if your a is happen to be e, don't forget that your log of e is 1. So that's why derivative of log of x is simply 1 over x. Okay, and as I told you, if we attach it with the chain rule, we can see that a derivative of log of u base a, it is 1 over u log of a, and then du by dx. Okay, and this one, if you got a derivative of log of u base e, you have 1 over u, and then a derivative of u with respect to x. Okay, just like that, simply. So here, if you want to find a tangent line of this function at x equals to 0, again, all what you need is to find f prime at 0, right? So here, to find that one, you need to find f prime at any x first, okay? So this one, a derivative of e is just what? E to the x itself. A derivative of log, this one is a u, okay? It's not an x, right? So it will be 1 over u, and then a derivative of this u with respect to x, and then a derivative of x, that one is a 1, okay? So here is simply 1, right? So we got e to the x plus 1 over x plus 1 and 1. So if your x is 0, okay, if your x is 0, you got e to the 0, this one is 1, and this one is another 1, so you got a 3. So the equation of the tangent line becomes a what? Y minus the point that it's passing through. So at 0 here, your f at 0 is a what? E to the 0, log of 1 and 0, and log of 1 is also 0, so you got a 1. So it is y minus 1 equals to your slope 3x minus 0, or you can say that it is y equals to x plus 1. This is the equation of your tangent line. Okay, okay. And actually, we can actually saying that a derivative of a logarithm of the absolute value of x, okay, we are not going to show, but we are going to use it, okay. It is not only the x, but if the absolute value of x, you can also find that a derivative becomes 1 over x, okay, for each and every x that is not equals to 0. So all what you need is the logarithm of the absolute value of u becomes just 1 over u, and then du by dx whenever your u is not 0, okay. So this is what we are going to use, okay. So now, to find this kind of derivative, okay, let us look at this one first. For the b, your y prime, okay, it is like almost look like this one, right? Okay, it's look like this one. However, sometimes we may need to uh, manipulate a little bit. Actually, derivative of a log of the absolute value of u base a, it is 1 over u log of a, and then du by dx as well, if your u is not 0, you see. So this one, it happened to be log base e, so the log a here, I mean the log of e here just happened to be 1, okay. So here your a is 3, right? And this one is your u, you see. So it is what? 1 over u, and then log of what? Log of 3, and the derivative of the one inside, which is 2 minus sine of x. So it's just simply that we forget all the absolute value, okay. So here on top, a derivative of 2 is 0, a derivative of sine is positive cosine, but you still have that negative. So we have negative cosine 2 minus sine of x, and then multiply with log of 3 at the bottom. So that will be your y prime, okay. What if we look at number a and number c, okay. If you look at number a and number c, we have a little bit of the trick, okay, so that it will help you finding a derivative easily. The first trick is that don't forget this one, the one that we introduced before. If you have a log of w raised to the power z is the same as the z and then log of w, so that this one actually it is a log of x cubed plus 1 raised to the power 1/2, right? So it is the same as w raised to the power z. So we can just kick down first. So what we have, okay, this is a y, okay, not a y prime. Just rewrite it. So you got 1/2 and then log of x cubed plus 1. So it's just simply a log of u, right? This one either having absolute or no absolute value, I mean the derivative will be the same. So it means that if you want to find a derivative, this is 1/2, and then 1 over u, and a derivative of u multiplied, so you got 3x squared. Okay, again, it is multiplication. So as a fraction, when you multiply, it need to multiply on top. So here we have 3x squared over 2x cubed plus 1. Okay, and you may try by yourself if you just do this one directly without using this, you know, properties. Okay, you try this one directly, and then you see that why we should use this property. Another property that we may need is that a log of something base, that one, it will be a log of base e over a log of base e of that base. Okay, all right, so this is another properties that is that we will use a lot. So that this one, you see here, the base is not a number, there is also not a number, there's all functions. So it means that you need to rewrite this one into two functions divided, okay, as shown in that property. So actually this one, it is the same as log of arctangent of x squared over a log of 5x. And then actually this is, I mean, another properties that may help you is that a log of what? Wz, it is a log of w plus a log of z. So that actually this one, it is the arctangent of x squared over log of 5 and log of x. And don't forget that a log of 5 is simply a constant. Okay, so that when you find a derivative, it becomes 0, right? And again, the other thing that you may need to keep in mind is that if you see this one x squared, it means that the square is at the x inside. It's not like the arctangent square x. This one is the square outside, and then you can pull out, if we have a log, okay, we can pull out that one in front of the log. But this one you cannot, because the square is within the arctangent. Okay, so again here it's just the rewritten version of your y. But if you want to find your y prime, you start from here. So it is a quotient, right? So it is the bottom, okay, derivative of the top, which is 1 over the u, and then a derivative of the u, all right, minus the top, okay, and then derivative of the bottom, derivative of log 5 is 0, derivative of log of x, it is just simply 1 over x over your bottom square. Okay, so if you want, then you can just keep, you know, copy this one, log of x, and then over the arctangent of x squared. And what is the derivative of this one? What's the derivative of this one? The arctangent. It becomes what? 1 over 1 plus u squared, and then a derivative of the inside, which is 2x. Okay, which is a derivative of x squared, right? So you got 2x. So we have 2x over 1 plus x fourth. You see x fourth here, x squared and then square. Okay, and the rest we just copy, right? So you have log of arctangent of x squared over x, and the whole thing divided by log of 5 plus log of x squared. Okay, all right. So at this moment, how many formulas that we already have? We have a formula for finding a derivative of a constant, and then x to the power r, and then exponential e to the x a to the x, a logarithm, okay, the trigonometry, the inverse trigonometry. So we have like almost all of the formula that we needed, okay. So the rest, it will be just the one that you will need to mix it to combine it together. For example, you may need to use a product, you may need to use the quotient, you may need to use the chain rule, you may need to apply the implicit derivative, okay. So we are going to stop this video clip right here first, and then we will see you on the next one with like, if sometime our function is so complicated, okay, and how can we simplify it first and then use the either a logarithm and the implicit function to help you finding a derivative more easily, okay. So we'll see you then. Bye bye.